Hi there, I'm Matt from Code Wizards. In this video, we will be taking a quick look at how you can speed up your debugging process by using your local machine as the dedicated server for a multiplayer game using GameLift. We'll be using the Unity engine with AWS's sample game as an example. First, you'll need a version of the Unity engine that's supported by the AWS GameLift C# Server SDK plugin, which for this tutorial is the 2022.3 LTS version. Once you've got that installed, create a new project with that version of the engine selected in Unity Hub. Whilst that loads, let's download the Unity GameLift plugin, which is available on GitHub. On the date of recording, 3.0.0 was the latest release, so we'll be using that. Once that's downloaded, extract its contents. As the project is still loading, we'll move on to another step we'll need later. You'll need to navigate to the AWS console and create an S3 bucket. Here I've created it with entirely default settings and given it a name that we will use later. Be sure to take note of the region that you've created this in. Once that's been created, you'll also need to create a GameLift fleet and add a custom location for the fleet. I have a location here that I created earlier, but to create one you just have to click the Create Location button and give it a name. Now that's done and the Unity project has loaded, we're going to install and configure the GameLift plugin, as well as install the sample game to test its working. To do this, navigate to Edit, Project Settings, and then select the Package Manager tab. As per AWS's tutorial, you just need to add the Unity NuGet scoped registry here. Then move on to installing the plugin by going to Window and Package Manager, then clicking the plus in the top left and selecting Add Package from Tarball. Navigate to the directory that was created by extracting the plugin zip downloaded from GitHub earlier. To install the Server C# SDK, go to File Explorer, navigate to the directory that the extraction of the zip created, and extract the zip within this. It contains the tarball for the Server C# SDK. Once that's extracted, head back to the Unity editor and Package Manager window, and repeat the same process by clicking the plus and Add Package from Tarball. Then navigate to the directory just created by extracting the inner zip just a moment ago, and select the tarball within. This will install the Server C# SDK. We're all done with the Package Manager now, so close that window, and navigate to the top menu, to Amazon GameLift, select Sample Game, and Import Sample Game. Make sure that all the components are selected and import them. Once that's done, go to the same place and select Initialize Settings. Now the final step of configuring this is to go to Amazon GameLift and set up your user profile. Scroll down and open your credentials file from here, if it's been able to find the credentials file. Make sure to add the region that your S3 bucket is in, which in my case is EU West 1, as well as, of course, your access key, ID and secret. If you haven't set up the AWS CLI yet, there'll be a link in the description to AWS's website where you can do this. Also, you'll have to add an access key to your user in IAM, which you can do by going to IAM in AWS console, clicking on Users, searching for your user, and then within your user, select Security Credentials and add an access key. Anyway, to get the credentials file sorted and working in the CLI, follow the AWS guide, which I'll include in the description. Using AWS Configure will populate the credentials file in the default location. So to test that's worked correctly, make sure you've navigated in the Unity editor to Amazon GameLift, and then set up your user profile. Then click on the little radio button next to it where it should say Default, and then click Select Profile. Once you've selected the profile, click Bootstrap Profile and enter the name of the S3 bucket that you created earlier, and then click the Bootstrap Profile button to complete the operation. Once that's done with visual confirmation of its success, click on the Anywhere tab under Hosting Solutions, and you should be able to populate this page with the Anywhere fleet you've created, and then should be able to register your local device with the IP set to 127.0.0.1 as a compute resource within this fleet. Now go to File and Build Settings and create a build for Windows. This will generate you an executable file for running your game. Once that has been completed, go back to the Amazon GameLift tab in your editor main window and select Launch Server in Editor. This will then create a server build and run it in the editor. Whilst that build runs, a small detail worth noting about the sample game is that the client is not authenticated before making calls to the GameLift service. So best practice would be to set up a backend server that authenticates the user and then makes calls on their behalf. AWS provide a draft architecture diagram of this in the README of the GitHub repo for the sample game. The link for this will be in the description as well. Upon your server build launching, launch an instance of the client build that you created earlier with the executable, and after signing in with dummy credentials, click Start and see that the log for the server recognizes this and activates a game session for the client to join. You'll know when the client has joined the session because it will show in the Unity console output. The game client will show the same screen as the server, and the server GUI will show that one player is connected. You'll notice that I opened 2 instances of the game client, and if I log in with dummy credentials here too, I'm able to join this game session, which the server's GUI confirms. When I quit using the quit button, the server GUI will show that the GameLift service, and therefore the dedicated server, is aware that these players have left the game session. Thanks for watching this video. We hope this might help you to save iteration time when developing a game that utilizes GameLift, so you don't have to wait for a new server build to deploy to an EC2 dedicated server, which can take well over half an hour depending on the size of your game binary.